Previously, we installed three compilers to write our C program. Today, we are going to understand the internal of C and how C works. I would like to talk about portability in C before we dive deep into the explanation of our hello world from our previous video. We all know that C program can run on any platform because the code is translated into machine binary, which is executed by the processor. So all we need is a compiler for the platform we are writing our program on, be it a Linux or a Microsoft desktop or a Mac, Android embedded system, and so on, be it any platform. All we need is just a compiler for that platform. So the compiler has all the implementation of the C standard. Okay, firstly we have to know that C was created in the 1970s with the first standard known as the ANSI C, or also known as C89. Okay, this become an international standard called the ISO CEI 9899 1990, or just C90. This is also referred to as ANSI C. Okay, this is the first international standard of C. Okay, now what is a standard? What do I really mean by a C standard? So C standard are just releases, like they are the rules that govern how C program should be written. Okay, so these are all documented, and the compiler, what the compiler does is implement the instruction found in the C standard and with more, because there are some rules which are not found in the C standard but are being implemented by your compiler. So that is why that is why some things can work on different compilers than another. For example, there can be a feature that works on MSVC compiler and will not work on Clang or GCC. Yeah, all the codes written on this tutorial is going to run on all the compilers installed because we are learning the C standard, but things might happen on different compilers, okay, differently based on your implementation of the C standard. At the time of creating this video, currently we have C11, but we are approaching 2021, which C17 is going to be released next year, also known as C2X. Okay, depending on your version of your compiler, some features might work based on the standard. That simply means, for example, if you have a compiler, for example, let's say GCC, which was released in 2015, and we have C17, which will be released next year, that compiler will not have all the newer features which will be released in C17. So it is always advised for you to install the latest version of your compiler. Okay, now also during compilation I'm going to show you the flags which we are going to use during compilation, because you would like to compile your C program based on different standard. For example, during compilation you will use a flag \std equals to the C standard which you would like to compile your program to. Now, why will I talk about C standard? The reason is because I want you to understand portability in C. Okay, writing a C program, developers or programmers are encouraged to conform to the standard, okay, as doing so help portability between compilers. But there are some rules which are not governed by the C standard or described in the C standard but are handled by the compiler. So this is known as implementation by the C standard. It won't take you a while before you start hearing jargon such as undefined behavior, unspecified behavior, or implementation defined behavior. As a beginner, I want us to get familiar with all of these terms, because writing a C program, you will face such error which will be produced by your compiler saying undefined behavior. Now, what is an undefined behavior? When some errors occur, the compiler is free to choose how to manage them. Okay, it might generate error, ignore them, or provide specific result. For example, overflow is an undefined behavior. I know this might sound jargon to you right now, but I just want you to just know this, okay, because in your whole career as a C programmer, you will one way or another face with a problem that the compiler will tell you undefined behavior. So I just want you to get familiar. Undefined behavior should be avoided at all costs. Okay, when you're writing your program, make sure not to have an undefined behavior. Meanwhile, implementation behavior must be used into the right way in order to have expected results. The C standard gives choices to the compiler to handle some behavior, okay? The choice might be described by the documentation of the compiler, or it might not. For example, the evaluation of arguments order in a function. So therefore, different compilers might handle function evaluation differently, okay? For example, GCC might evaluate function orders from left to right, or Microsoft might evaluate function order from right to left. Actually, that is not actually what it is. I'm just guessing. If you want to know that, you should write a simple, for example, the example displayed on the screen. You should write this function and implement it differently on MSVC and GCC, and you will see the results might be different because the C standard gives choice for the compiler to handle this kind of action differently. Finally, what is implementation defined behaviors? Okay, so previously I said unspecified behaviors, the system that gives choices to the compiler to handle some behavior which are documented or not. Implementation defined behaviors are those unspecified behaviors which are documented. For example, the number of bits composing a byte. Okay, this is well documented in the compiler. I want to wrap this small discussion talking about compliance. Now, what is compliance? Okay, the C standard consider two kind of environment. Okay, we have a translating environment and an executing environment. Now, what is a translating environment? In a translating environment, the environment is a system allowing compiling C program for an executing environment. Now, an executing environment is a system that runs the compiled program from a translating environment. I hope that makes sense. The system that distinguishes two kind of executing environment. Okay, we have the hosted executing environment and standing executing environment. Now, what is a hosted environment? A hosted environment is an operating system having several facilities such as files that can be used by the program. The compiler used in a translating environment to generate binary programs for a hosted environment is called a hosted implementation by the C standard. Okay, so this is by default the compilers we just installed, because these compilers permit us to write program which can be run on our operating system, like the Windows we have right here. Now, what is a freestanding environment? In a freestanding environment, we don't have all the facilities that are found in the operating system. For example, a freestanding environment is a firmware that manages an embedded system dedicated to specialized tasks. A program running in a freestanding environment can use only a subset of the feature defined by the C standards. The compiler here are known as freestanding implementation by the C standards. It uses only a limited set of libraries corresponding to the header files. For example, float.h, standardint.h, limit.h, iso 64.h. So this in this environment, we just use only a specific header which is going to be used on our environment. Okay, the environment here is known as a freestanding environment, which don't have all the facilities which are found on your normal operating system. For example, writing a firmware for an embedded system, we don't need all the file inputs and outputs, just is simply because in an embedded system we have limited amount of resources. Okay, so here we are going to use a subset of what is found in the C library. Okay, one thing I want to talk about the hosted implementation compiler and the freestanding implementation compiler is that with a hosted implementation compiler, you can write a program that can be executed on a freestanding environment. Meanwhile, with a freestanding implementation compiler, you cannot write a program that can run on a hosted environment. This is just simply because with a freestanding implementation compiler, you don't have some features which might be needed on the hosted implementation, on the hosted environment. Sorry. In this course, we are going to be using a Visual Studio which has MSVC, and we are going to also run some code in GCC. Okay. A C program is a human readable file. Okay, the file usually ends with a .c file extension, but this is not mandatory because a compiler don't care about a file. Okay, the .c extension is just for you, is just for other programmers to see the file and say, okay, yeah, this .c just simply means is a C file extension. It is also used by code editor to highlight syntax, okay, because for example if you put a .c, the code editor is going to understand that this is a .c file and is going to know the syntax specific to a C standard. Okay, now that being said, file don't really matter by the compiler. Okay, you can start creating any file extension. For example, you can tell MSVC that this is a .cj file and compile this as a C file. Okay, how can we do this in MSVC? It's very simple. You just come to tool, I think options, so you go under tools, option, text editor, file extension, and now you can create your own extension. For example, you can see I have a .cj extension which is been mapped into a Microsoft C++. Okay, so that is just it. The compiler don't care about your file extension, but it is just a standard, and it's a good practice to always write your file and you name it with anything .c, so that the compiler or any other programmer viewing your file can know this is a C file. Okay, a C program is made up of set of action known as statement. Okay, this statement tells the computer exactly what to do. Now you can see on this hello world program we have statement, but one thing you have to know is anything beginning with a hash include is not actually a C statement. Okay, this is something known as preprocessor derivative. Now what is a preprocessor derivative? A preprocessor derivative is a macro. We are going to talk about macro later, but macro just simply means action. Now in this case, the hash include macro is just telling the compiler to copy. Okay, so each time the compiler sees this hash include, is going to copy what is found in the standard into the standard input output header, on what is found in the standard lib header. Okay, so that is what the include means. So now there is one thing I will talk here, which I'm going to talk a little bit later, before your compiler actually start compiling your program. Now what is compiling? Compiling just simply means taking all this human readable syntax and translate it into binaries. Okay, that is what compile. Before compilation actually starts, the preprocessor are first executed first. Now preprocessor execution is not actually part of compiling. Okay, it is not part of compiling. What the compiler is doing is just copying what is found in this header file and pasting here, which the hash includes preprocessor. So if you want to see all what this preprocessor derivative evaluates to, you can simply right click on your hello world program, go to properties, and you take preprocessor to a file. You select yes. I'm already select this, and you take OK. Now let us compile our program. Now if you want to add this compile button here, all you have to do is you come here, add a remove button, you go to customize, and you go to add command, you go under the build, now you select compile, and then you click OK. Now I already have that. Okay, so you click on your compile button here, it's going to compile your program. Now the way C store its file is a little bit weird. So under your solution hello world debug, and you see this .i file extension, you right click, you open with your favorite code editor. Okay, so you can see this file is very huge. It is like how many lines? It's like 12,935 lines of code. Okay, this is our hello world program. Now you can see up the program is all of this massive std input output, and that is what this preprocessor evaluates to. Okay, so remember, just know a preprocessor is a macro just meant for the compiler, and in this case hash includes just simply means copy. Okay, so after our include statement, we have our int, we have a function, we have an int main function. Okay, now in this case this function is called main. Okay, this is simply the entry point. That is where the processor will start executing the statement. Okay, remember I said a C program is just made up of statement, that is telling actually what the computer has to do. This main function contains statement which the computer is going to execute, and this main function is a special kind of function because it defines the entry point of your program. Now each program in a C world, or each program written in C must have an entry point. Okay, now it doesn't necessarily have to be the main. Now you can change your entry point. For example, you can right click on your project here, you go to properties, I think you go under linker. Under linker, you go under advanced. You can define your entry point. You can define any function to be your entry point. Okay, it don't really necessarily have to be the main, but the point is there must be an entry point. Now the entry point, like I said previously, is for the computer or for the processor to start execution. Like it is the starting point, entry point, starting point for execution. Now in this case, this main function has an int. This int here is a type. Okay, it is telling the compiler or the computer that this function returns an integer, but you can notice here I have commented. I forget to talk about comments. Now if you want to comment in C, you just put a double slash, or you put you comment like this. This one is for multi-line comments. You can write your comments here, multi-line comments. Now this one is this double slashes is for a single line comment. Okay, that being said, in this case, if I comment out this return type, I'm going to talk about return exit success a little bit later. Before I explain what is the return type of the main function, let me revert back the preprocessor to a file, because previously was set to yes, and if you read under here, if you set your preprocessor to a file, it won't produce an object file. Okay, so let us set it back to no. This echo $ with a question mark just shows the exit status of the last command. Now, why is it displaying 0? Meanwhile, in our main program, we haven't returned anything. As you can see, this line here is commented. Now, this is a special case in the main function, because the main function has to return a value, and if you don't specify it, it's going to return 0 under Unix system. Okay, under Unix system by default is going to return 0. The return value is a value between 0 to 255. Okay, anything apart from 0 simply means failure. Now you want your program to return success, you can just simply write 0. This is something which is not going to be handled by all the environment, because simply on Unix-like operating system, 0 means success, meanwhile on anything apart from 0 means failure. Now on other operating system, for example Mac, 1 can be success and 0 can be failure. So for you to have something known as portability, it is advisable for you to write exit underscore success. Okay, because this is defined in the compiler. Now the compiler is this exit underscore success is a macro which is defined in the compiler. If I highlight it here, we can see it expands to 0. Okay, so that is what exit underscore success means. Now this code is portable on all platform, because if I use any compiler here, the compiler is going to expand the macro into what the success flag of that platform is. Yeah, I hope this actually makes sense. Yeah, within this function we have a printf. This is a printf statement. If I comment out this line and I compile this file, the program is going to compile successfully. Now you might ask yourself, why is this program compiled successfully? Because if you are from C++, the compiler is going to produce an error. But in this case, we can notice here that the C compiler has actually assumed that this function printf returns to us an integer, which is kind of weird for the compiler to assume this, because as you can see, this is just we are just calling the printf function, and we are passing in some strings, and there is no definition of this. We are going to talk a little bit further about this. Okay, just bear with me that if you create a function in C without a body, the C compiler is going to assume that the function returns an int. Why is it assuming this? This is just because of backward compatibility. The fact that this compiles successfully doesn't mean you have to do this, because now this is something known as a linking error. We are going to see this just shortly. This compiles successfully because the C compiler has just assumed that this print function should return an int, but this print function doesn't have a body. Okay, so for us to use the definition of printf found in the standard input output header, we have to include the file, because this file contains the definition of the printf function we want to use. So let us uncomment this, and we can notice here that we have to pass in the argument of the function by just simply saying hello. this printf function here is defined. The function body is found in the input output header, which you can right click here and you can go to definition, and you will see how the printf function is implemented, which is kind of weird for beginners to understand. More on this later, because in this course I will actually be looking at the implementation of some of the function that the compiler is actually executing, so that for us to better have knowledge of what the compiler is doing, and for us to also see what is being implemented by the C standard. Okay, we can notice here that this function has a semicolon. The semicolon just simply means it's an end of the statement. Okay, and here we have a backslash n here. The backslash simply means the console should jump to a next line after printing this string. Okay, it should jump to a next line. Yeah, so let us move forward. Yeah, we also have another function on a system post. This system post here just simply means it is actually the definition of this function is found in this standard input output library. As you can recall, if I comment this line and we compile our program, it is still going to compile successfully. It didn't compile successfully. Yeah, this system post is going to compile successfully, but the macro, which is also defined under here, won't. Okay, yeah, this macro won't, because the macro is defined here. One thing we could simply do in order to remove this error is to hash define this macro by saying exit underscore success 0. Yeah, we could define this macro here, exit underscore success 0, which is gonna work fine. So this is another macro here which is defining. Okay, this is your target, and this is the variable or the name that you want to call your macro in, but this is what the macro is being set to. You can notice here 0 is a literal which is being typecast into an int. More on this later. I don't know, I'm throwing a lot of stuff on you guys. I hope you can pick it up. More on this later. Okay, so we can notice here that if you comment this includes, we have noticed the system post still works as expected. It returns an int, which that is not the case. So if you want to use the real function which is defined under the standard library, you have to uncomment this line that contains the definition of this system post. Okay, actually is a function in C. Now remember, I said a C program is made up of statement. Okay, so think of a function of a group of this statement which are grouped together for a specific task. Okay, that is what a function is. Now I want to talk a little bit about translation unit, what a translation unit is. Now we notice that our C program has file. Okay, now a file is something known as a translation unit in C or in C++. Okay, because each file is going to be compiled into an object file. If we come, you can see our object file. Okay, each file compiled separately is going to produce an object file. This object file is something known as a translation unit. Now you can have a lot of file. A C program is usually made up of a lot of file, not just a simple hello one word file. A C++ program is made up with a lot of file. Okay, we can have other files here, and each file is going to produce an object file. Now if you include file together, it's going to produce you one big object file. Okay, not necessarily all file cannot necessarily produce an object file, because if you don't include files together, it's not going to produce you an object file. But if you compile each file separately, it's going to produce to you an object file. So I just want you to understand what an object file is and what a translation unit is. Now what is linking? Linking is the process of finding where each symbols and function resides and linking them with your definition, that is connecting them. Okay, for example, let us write a function called sum that returns the sum of two integers. Our program here building is just simply compiling and linking. If we build our program, we are going to see a linking error. Okay, by the way, we have seen a warning here by the compiler. The compiler is telling us that sum is undefined, but it is using an assuming returning of int. Okay, that is what the compiler is telling us. And if we scroll down, we can see something known as an unresolved external symbol underscore refrain, and we can see the error code started with an lnk. This just simply means we are using a function which the linker cannot unresolve the symbol. Okay, we are using the function, and the linker is trying to link this function to the function body, and the linker cannot find the function body. Assuming that this function body is found down here, that returns a double, and and we define our function like this. Let us build our program again and see if we are going to have an error. Yeah, we still have an error. Now you might be asking yourself, why do we have an error? Okay, now we have an error because we have not tell the compiler, we have not tell the linker that this function exists. Okay, we have just given the body of the function, but we also need to tell the linker that this function exists. How can we tell the linker that this function exists? By just giving the signature of the function. Now the function signature is just simply this before the curly braces. We just copy and we paste up here, and we put a semicolon. Now by doing this, we tell the linker that, hey, this is the function signature. The function returns a sum, the function returns a double. Now if we run this program, I think it should run successfully. Yeah, we can see everything is successful and everything works fine. So that was one error we have seen, known as unresolved external symbol. So I would like to conclude this video by talking about duplicate symbol in C or C++. Now we have a perfect example of a duplicate symbol here. So here we have include sum.h. In sum.h we have a function called print that actually does nothing. So we also include this sum.h in another file called file1. File1 has a function called fun that actually does nothing. It doesn't matter if we are not calling fun. Okay, now in the main function of hello world.c, we are printing our hello one, then we are calling our print function. Now if we compile this file, is going to compile perfectly. Okay, but when it comes to linking, the linking is going to have an error in linking into print the body of the print function, simply because of the way the include macro works. Simply because of the way the include macro works. Because in the include macro, we are just copying. We copy everything that is found in the sum header file. Okay, so it's just like we copied this print and we paste it up here. We also copy this print and we also paste it in file.1. So when it comes in linking, the linker will not know the specific function to link to because it is ambiguous. The name is ambiguous. So the declaration of print is found in two translation units. It is found in file1.c and it's also found in hello world.c. So this is a perfect example of duplicate symbol in C. So I hope this makes perfect sense, and we'll be seeing a lot of this in the coming videos. So I just want to thank you guys for viewing, and if you like the content of this video, and which is a blast, I've thrown out a lot of information on you guys, which is also a perfect hint for you guys to do your own research. And if you have any question, feel free to comment it and I'll be very grateful to help you guys. So our next video we'll start talking about variables and data types, and we'll be going a little bit deep. As you all know me, we're going to understand how the computer actually stores variable, how the computer manages variable. Actually, it is not a necessary skill for a programmer, but I think it is very good for you to understand actually what the computer is doing under the hood. And that is that for the next video, and I just want to thank you guys for spending your time with me in this video. Thank you guys, and I'll see you back in another video.